That's a very good thing. I don't need to repeat what David said. I totally support whatever he said. Therefore, I'm going to represent the Dow side of it, a little bit higher elevated point of view that what direction we want to go. As you know, Dow Chemical is about $50 to $60 billion company. We have 52,000 employees, about 200 plants, and we're producing lots of different chemicals. And we have started in the last 15 years to start divesting and merging. Therefore, we never done that before. Therefore, by merging with Union Carbide, by Roman Haas, or separating from Styron, therefore, we are becoming a very flexible company from process automation. Before year 2000, every plant has same control system, same work process, and the crown of the jewels was what David did we call it latex and rubber business, because he was really automating everything correctly and everything was the same. But we have major projects coming along. We have we have Sadara, which is a joint venture with Saudi Aramco. It's a $20 to $25 billion project. We have Gulf Stream, that's about $5 to $8 billion projects. And we have about 700,000 IOs that's running with our Mod 5 systems. Highly automated, run like a charm. We add number of percentage per production, and they run all safe and reliable. And we want to migrate them, not because they are bad, but because we think we need to migrate them. And we want to worry about the next 20 years. To do that, in Dow, we made a decision about 10, 15 years ago. If we want to migrate, if we want to go forward, should we keep our own stuff, or should we go and start using standards and other equipment from manufacturers? We decided to align ourselves with ISA. Number one, when we talk about things, let's align ourselves with the ISA standards. Batch control is very good, S95, and lots of other ones, but these three are the main ones. And when we looked, there was nothing for continuous processes. Majority of the industry are running loop-based control, and basically we have started, I'm a co-chair of the ISA 106, and Dow is giving me time and to go and start having these standards. Therefore, when people ask, how do you control your processes? I say exactly the same way it's documented in ISA 106. But what is ISA 106? Again, as Dave mentioned, Dow has lots of batch controls, 20%. Continuous processes are about 70%, and the other 10% are discrete. My focus here is on continuous control. How are we going to migrate, design, and build new facilities focusing on continuous? Batch, we have been part of and S88, and we have learned a lot from them, and basically we are following that path. But on the continuous control, we are trying to bring our knowledge and technology that we have developed in the last 20, 30 years using the Mod 5 and bring it forward to the new platforms that we have. What does that mean? Again, at the very high level, if you just turn the S95 the other way, we have inputs coming in, going through our BPCS system. We have controllers and outputs coming out. And the operator via HMI sees our controller. And sometimes we add the safety instrument system if it's needed, and these two work in a harmonious way. Our system, 10 years ago, was the first SEAL 3 approved system. Totally integrated. One computer doing both up to SEAL 3. None of the systems that we can purchase today have the same capability. Like any other project that you do, whatever you improve, you go 70% of what you had before. Therefore, and you need to figure out how to change that. Therefore, you at least have the same or better of what you had before. Again, our system was very limited. As Dave mentioned, structural text. You need to have lots of discipline to manage it properly. Therefore, what we have done is, I just want to share with you what is we talk about process control, past, present and future. But my dilemma is that process control, we have added screens, we have added fancy control rooms, but we have not changed foundations. We have not changed from a loop-based control to procedural control. We have not changed to an intelligent point of view from the operators. Just look at these pictures that I just got from internet. We used to have these systems, and I want you to pay attention on 3 columns. The complexity of the processes, the control system itself, the control application, the software we develop to control our processes, and then how many valves per operator. That's a key indicator for me, how many valves a single operator controls. Because if you go and look, majority of time, the number of valves, these are analog valves, not digital valves. The number of analog valves is a good indication of the complexity of the process. Automation comes at the cost of having instrumentation. Just use any of your plant and go and divide the total number of I/O by total of number of valves. You can have something about 4 to 15 or 16. That's the range. If you divide total number of I/O by number of valves, majority of our plants run around 8 to 12. That means we have fully instrumented our plant to run them automatically. Therefore, we are hand-free or drivers-free operations. If I go forward, you see, the background is the same analog. Now we started to bring CRTs. We are still at 100 valve per operators. The code got a little bit complex. And by introduction of, I think, this is the time I started to become a control engineer. Now you know my age. Was TDC 2000, TDC 3000. And that was the first time that we just moved what was on the wall into the CRTs. We did not change anything. Today, the operators, to go from one CRT display to another CRT display, he needs to click. Therefore, it's like walking on the panels. There's still this concept of the panel is there. As mentioned before, we have these new engineers, and they come and look at our CRT graphical display, and basically the question is why we don't have a Google map. I mean, why can't I zoom up and zoom down? Why do I need to change between the panel and change the background? Why do I need to draw this panel? Once you have all of the SPI database of how the process looks like, why somebody needs highly paid engineer after 4 or 6 years of study needs to draw them again and then connect them again once you have the data in 4 or 5 places. If we go forward, this is the future. I go and look at what is the future look like. Okay, bigger control room, higher ceiling, nicely light, very big displays, but the content is the same. If you look at last 30 years, we haven't changed. It just went from the panel to what we have as a CRTs. Still, the operator needs to navigate between different pages. It's like a book. Still, we cannot zoom up and down. Still, we cannot ask ourselves a question that if I change this valve, who gets affected? Not by procedure, not by having an iPad looking at this box and then getting the documentation, but just if I click on that valve, why can't I just see the other valve? What's the relationship between these two? And if I change this, what happened to this valve? Or what happened to this temperature? We have all of the data, but our mindset is what we had before is good, don't change it. Underneath is basically similar things. But what we have done, if you look at this slide, is an older slide. All of our computers, when we started process automation, around 70s and 80s, they were very, very simple computers, PDP-8, PDP-12, and that concept of this structural language, structural code, the way everything works, stayed the same with us. Computers have become more powerful. My iPhone has more horsepower than the Honeywell system that I used when I started to work. And the stuff that I did for my PhD was 8K. Yes, and we had 1 meg memory that I have a hammer, wooden hammer that I could tap it to get it working. Therefore, we have come a long, long way. But in process control, we haven't changed. Therefore, the challenge is that this slide, the computing power in terms of MIPS will go same or more than the human brain in about 10 years' time. Therefore, are we going to have using these functionalities, this horsepower in process automation in 10 years' time? Therefore, let's ask ourselves, again, when we are doing, I like to talk about what we focus, and I'm leading the efforts how to migrate, as David mentioned, how to migrate all of our Mod 5 systems to our new selected control systems, and what are the issues we are coming up with when you go from one system to another. Number one is when you change the system, low power safety comes because you grandfathered it before. There was no low power when you built these things. Now you're migrating. You need to just rethink about all of those issues. Naming conventions, you think is very easy, but now you have three disciplines that you need to agree. In before we have our Mod 5 names, we have a PNID names. Now we have ABB names. These three guys need to agree who's called what. Controller, and basically all of the I/O boards are new. Therefore, we had these controllers for the last 20 years that all of the information came in was different. They're all 420 milliamps, RTDs, lots of different things. And what we discovered was very interesting is that once you have your own system and you go to a digital system, things are different. In our system, because we owned it, then we made it look correct the way the operator looks at it. True means open, false means closed. Whether the valve is fail open or fail closed. Whereas you go and buy any system, it's different. Yes? Therefore, it's not the same. Its operator is not a driver. The cheap software is the driver. Analog the same way. They can reverse. And how do you... And then the fault detections, all of this stuff about I/O. And then, as it mentioned a number of times, I don't have enough a slide, but hopefully next year or year after I come and share. How do you think out of the box, if you want to migrate, say, 500,000 I/Os in the course of next 15 years, similar challenge that David has, how do you think out of the box that you don't spend tremendous amount of money to rewire, to redo the things, to check again the stuff that works, yes? Therefore, in these sort of migration projects, the instrumentation is foundation. That's where the amount of money, majority of the money goes, and it must work on the spot, otherwise things won't happen. Again, when you're looking at the controllers, I'm not going through the details here, but what we have learned is that, as David mentioned, we need to use predefined objects. By predefined object is, if you build a controllers or valves or pumps, I'm showing at the low level or equipment module, then you don't need to test them. You don't need to figure out whether they work or not. Your job becomes much easier than going line by line and evaluating them. And then we need to evaluate performance with simulation. Dow has been great in terms of everything we do before we turn it over, we simulate. Majority of our plants, once we finish, when we go to a startup, they start up less than 8 to 12 hours. Therefore, we have a hydrocarbon plants that when we bring it up, it takes less than 3 days to bring up and full operations in when we shut it down and bring it back up after the hurricanes. Therefore, it's very important that the control information and the way we design controllers are all correct and all tested before. Therefore, we are not relying to test all of our pumps, all of our valves. Last but not least is the human-machine interface, how the operator will see this world. Majority of our operators or operations for these migrations, they come from a world of structural text. Therefore, they look at the structural text. They are very good in understanding how to read the code, how to analyze it. And they knew how to navigate because you're dealing with one code. Therefore, you can see everything. The new control systems does not allow us to have that. It's very nice. It has very nice visualization. But as it mentioned before, visualization can cause headaches. I mean, we do not show flares on our screens. We do not show pipes in different colors. Color means for us, and we have patented this, I guess, about 15 years ago, that color means for us something's wrong. Color does not mean all of our screen, if you go, is gray. There is nothing there. But if a pump have problem, a yellow dot will show up. And if we have a problem, a red dot will show up. Therefore, the operator interface is very important for us, and make sure that the navigation comes with it. That's one of my issues that I have with process control system that we choose, is navigation is panel driven. Yes, you just build one page and you can go from this page to another page. There is no zoom, there is no zoom in or zoom out or understanding how everything is going. Visualization of the logic with real data is tremendous amount of important for us. What that is, because we have automated our system with this procedural automation, the code sometimes for a block valve is about 10 lines long or 20 lines long, depends, 80 characters or 120 characters. Operators needs to have a very good visualization out of that massive amount of logic, which one is causing him not to go forward, which one is causing him to stop and needs to take action. Therefore, we have put lots of efforts. Therefore, the operator can see the logics. And then we go with the KPI on all of the pages, the critical information. The last thing is very important for us is the concept of when we're running our plant, the software that we have on our controller, without shutting down or without endangering or putting things on manual, we should be able to load new software, because improvement is a key part of our livelihood. We have new product, we have new equipment, we change things. Our hydrocarbon plants will go down every 8 years. I cannot wait 8 years to add a new load. I cannot bring them down because all of our processes, we don't have tanks between our units. Sometimes there are 8 to 10 units feed each other. If I bring one of them in the chain down, everybody goes down. Therefore, for that, we need to have these things that I think we label it load, evaluate, go. That means if I change the software, I should be able to load it, compare it with the running software, see the differences, agree with the differences, and then set the press go. Or just say, no, this is not right, I will change it. Therefore, what do we do in Dow? Again, I want to put the emphasis on that if you want to go, as David mentioned, we're running something called a state-based control or unit-based control. That the operator is basically in charge of observing the process, not running the process. Therefore, he needs to make some decision at some points to start it, to move it to the run, and when the alarm comes, to answer it. But basically, our discipline, operator discipline, is embedded in our automation systems, and we are not running things as a loop-based control. Now, therefore, to be able to do that, these are some of the principles that we have, or requirements, that we need to be able to repeat or start up, run, and shut down. Therefore, every time we start a plant, a unit, an equipment, is identical to the last time we have it. Therefore, we have the best operator on board all the time. We can manage abnormal situation. Majority of, if you go and count the number of controllers you have in your plant, PIDs, PI controller, divided by the number of valves you have, you end up, our industry average is about 1.3 to 1.6. In Dow, we are running at about 2.6 to 3.2. That means we don't have a 0.2 controllers, as you know, is a statistic. But what we have is we have these abnormal management controllers. If a pressure goes up, I don't send the alarm and shut the process down. I have a PID controller that manages the pressure, and it come and override the temperature controller. Therefore, the operator doesn't need to take that action. Again, we automatically enables all of our equipment, devices, controllers, and we use something called mode of operations. Tomorrow we have a talk by our colleague from ISA 106 about ISA 106, procedural control for continuous processes. Please attend that. We talk about automatic swapping of the redundant equipment, pumps. For example, our pumps automatically swaps without the operator involvement. We are enabling, again, the operator to run a process unit instead of individual devices. Therefore, if you ask me where we are in the number of valves for operator, I think we are in a very high number compared to the rest of the industry. Therefore, the number of the operators that we have on board for our facilities are much less. When we were started to work for Aramco, I remember our friends count the car outside because they couldn't believe we have that so many little operators for these facilities. Therefore, the number of cars are the number of operators working inside. Therefore, that was a proof that we didn't send somebody in a room to hide. Last but not least is automatic sequencing of the plants. All of our sites, not only the units start one after each other, but the plant start in a sequential way. Therefore, and we want to bring all of these utilizing control equipments that we purchase or we buy, and we would like to use them. Now, therefore, what I'm asking for future, what do we need to change to have a better future? In HMI, what I would like to see is dynamic arrangement. Therefore, we should have these fixed panels, but like Google Map, it gives you options. If you want to have this valve and you want to shut it down for repair, what are your options? Therefore, why is not popping out automatically? Why do we need to read lots of Word documents to figure that out? None of the vendors provide us with cause and effect, which is all in the software. Therefore, it's reverse engineering of the software. If I close this valve, what can happen? What other valve will get affected? What other measurement will get affected based on my process knowledge and based on my software knowledge? Then we talk about object-oriented or any other system that we have in terms of programming. I was shocked when I started to learn how we do programming that, yes, we have objects, but one needs to go and type everything by hand. All of the linkages between the objects, all of the programmings that you need to do, it's a huge number of code that somebody needs to write. Now is in the language like C++ or very difficult from my point of view, old type guy. And then I started to say, okay, object-oriented, I will learn how to develop an application in iPad. It was just 2 days work. You just take this stuff, read it, all of everything is available. You just do what needed for you to do to make that application. I mean, my application was not a great application. It was that snake thing going around and hitting the wall, but was very easy to develop, yes, and understand how to develop it. Therefore, we are lacking. And what I see that we hired, for example, in one of my projects, 8 brand new engineers, control engineers, and they are programming. And they are about 10 times more efficient than all the other programmers I have on the other project that they have 20 years experience because they are not scared of the code. And this is a very simple game, yes, that they need to put and get rid of the errors and get it going. Management of change is something we don't have. We talk about it. We have developed our own things. Therefore, but if you change something, why can't we know what is changed? What's the effect on other things? And then on simulation, I would like you to leave you with the thought that we have the PNIDs, we have the SPI, how vessels, the sizes, the pipe, they're all in computers. And we have a steady state design in Aspen or HiSim that how everything works. But then we start all over again and we develop simulation for ourselves, yes, how the whole process works. We reinvent the wheel again and we are not using any of the information available there. Therefore, basically, in Dow Chemical, we are trying to move to commercial platforms and utilize the commercial platforms for our futures. We are very successful. We are just having 2 pilots coming up with the migration. But we are discovering lots of things that is not the old system we have was a little bit better. Therefore, we need to make sure that we bring the good stuff across and team up with international committees like ISA to make sure that whatever we define is coming from an standard community and use what we can buy out of the shelf and use the commercial libraries that we have, if they are available. Otherwise, we need to improve them. In this slide deck, I left you with few slides, I think 10 or 20, at the high level of what does the procedural automation do, but I don't think we have time to go through it. But please join David Emerson tomorrow for his talk about ISA 106. Thank you.